what did you think about Tesla's initial idea that Westinghouse shot down to sort of broadcast electricity so that people could just pull it out of the air?
His contributions to electromagnetism are real and recognized in the world of physics.
Imagine uncovering a device left untouched for 8 decades, only to watch it spring back to life and defy modern scientific expectations. This is not the plot of a science fiction novel, but the astonishing reality scientists faced when reactivating one of Nikola Tesla's most mysterious inventions.
He had some ideas that were a little out there on a level where it almost certainly would have not worked. What good is it? That's not the point of it. The point is to transmit information.
Could a technology abandoned so long ago hold secrets that challenge what we think is possible? What hidden powers lie dormant in Tesla's forgotten creation? And why did it disappear from history in the first place? These questions set the stage for a journey into invention, mystery, and rediscovery. The forgotten device awakens. In a quiet laboratory almost hidden from the public eye, a forgotten machine built by Nikola Tesla was brought back to life after spending more than 80 years dormant. Scientists gathered around in disbelief as ancient coils and copper components hummed and pulsed with electricity, displaying behaviors that modern technology struggles to replicate. This was not just a curiosity from the past. It was a device whose revival seemed to challenge everything we thought we knew about energy and machinery. The unexpected reactivation sent ripples through the scientific world, stirring excitement and skepticism alike. What made this machine so extraordinary was its almost mythical reputation among Tesla enthusiasts. For decades, scattered references to its design hinted at a technology far ahead of its time, yet concrete details remained elusive. When researchers finally located the original device and managed to restore power to it, the results stunned even the most seasoned engineers. Despite advances in technology since Tesla's day, the machine operated in a way that seemed counterintuitive and mystifying. The moment the machine came to life, sensors recorded unusual electromagnetic patterns that defied conventional explanations. Scientists noticed energy outputs that exceeded what the input power could account for, raising profound questions. Was this an early form of free energy, or did Tesla simply stumble upon physics that modern science has yet to understand? The machine's peculiar behavior immediately prompted a renewed investigation into Tesla's patents and notes, many of which had been forgotten or misunderstood for decades. The mystery deepened when it became clear the machine's design was unlike anything in mainstream electrical engineering. Key elements were arranged in unconventional ways, combining principles that rattled established scientific frameworks. Some researchers speculated that Tesla had built-in safety mechanisms and unrecognized quantum effects, while others believed the device might tap into unexplored natural forces. Yet, no definitive explanation could be offered quickly. This delay only fueled the intrigue surrounding the machine. Despite its mysterious function, what was undeniable was the machine's resilience. After 80 years of inactivity, exposure to dust, corrosion, and neglect, it powered up remarkably smoothly. This fact alone baffled engineers who expected components to have deteriorated beyond operation. The enduring craftsmanship and choice of materials hinted at Tesla's deep understanding of longevity and timeless scientific design. Even more puzzling was how little recorded knowledge survived about the practical use of the machine. Unlike Tesla's famous Tesla coil or wireless transmission experiments, this device was enveloped in silence, almost erased from technological history. The clues Tesla left behind were cryptic, often sketch-like or conceptual, forcing modern minds to rebuild interpretations painstakingly. This lack of documentation amplified both the challenge and fascination of reanimating the relic. Initially, the laboratory team treated the device with extreme caution, limiting operation times and constantly monitoring energy fluctuations. What they found was a dance of electrical phenomena that pointed to a source of power different from standard generators or batteries. Energy seemed to flow from nowhere or from the environment itself, in a way that conventional models could not predict. Still, confirmation required much more experimentation. The revived machine immediately sparked conversations about Tesla's true ambitions and whether this technology was meant to revolutionize power generation. If this device held aspects of clean, self-sustaining energy, why was it abandoned for so long without being developed? The unanswered questions hung heavy over the room, creating a suspense that urged deeper analysis. This was just the beginning. Scientists knew unlocking the full potential and understanding of the machine required patient exploration. Many expected that by the end of this investigation, long-held assumptions about energy, magnetism, and physics might be forced to change. What exactly Tesla engineered in secrecy was something the world was not yet ready to fully grasp. But very soon, the pieces would begin to fall into place. This newfound awakening of Tesla's forgotten machine invites us to explore the man behind its creation and the visionary ideas that motivated such a groundbreaking invention. Tesla's vision and ambitions. Nikola Tesla was an inventor driven not only by curiosity, but by a kind of almost prophetic imagining of what comes next. He talked in his own mind about technologies that might give humanity unlimited, spotless energy, so people could live without being tied to the old power habits. The machine that was now reactivated, well, it sat among his biggest, most intense projects, and it was meant to reach energy in ways people of his time did not really grasp. Tesla thought these inventions could change daily routines and reshape the energy systems we use, like the whole world was waiting for a new wiring idea. Now, unlike the more celebrated inventions, the alternating current system, or the Tesla coil, this specific machine came from a slightly different train of thought. Tesla tried to make use of what he called radiant energy, an unseen influence in the surrounding space that, if you access it correctly, could offer power without major waste nor pollution. He pictured a setup that didn't simply convert electricity, but instead tapped natural energies that keep renewing themselves, pushed forward by the sun and cosmic rays. It was pretty much a breakaway from the usual fossil fuels and from standard ideas about electrical storage. Tesla's own notes and patents from the late 1930s into the early 1940s sort of suggest a device that was meant to be both efficient and kind of self-sustaining. In those writings, he talked about parts that drifted away from heavy fixed machinery toward smaller packed assemblies, able to produce electricity with not much outside help. The whole arrangement, if you look at the way he described it, had coils and circuits set up to ring or resonate at frequencies meant to match natural energy movements. That kind of resonance mattered a lot, because it was the key Tesla thought to opening up the power he was theorizing about. At the same time, his goals weren't just technical, and not purely scientific either. Tesla framed the invention as a tool to bring peace and prosperity around the world. He was convinced that if people could get free, or near limitless energy, then the underlying causes of fighting and poverty could be pushed out, erased at the root. The intent was humanitarian, essentially to make energy access broader, so inequality could be reduced or at least stopped from widening. In his mind, the machine wasn't only a concept, it was supposed to make that dream show up in real form. But Tesla was, painfully aware too, of the problems that his ideas could bring. Established industries and governments too had reasons to resist, and he ran into money troubles, a lot of doubt from the scientific circles, and political pressure that narrowed what he could actually complete. It's often said that his most radical systems got delayed, sidelined, or even suppressed, which might explain why so much of it later vanished from public documentation. So the forgotten machine, it stands in a way for all those frictions and losses, the hopes and the near misses, all tangled up together. In Tesla's later years, he kept on refining the idea, kinda adapting his blueprints to dodge technical obstacles, and I mean, really focus on it. His writings show a man who was really fixated on precision and small particulars, understanding that even the tiniest misstep might stop the machine from getting to the power it was supposed to reach. So it's a bit striking that the device revived today still seems to mirror this same careful craftsmanship. plus that theoretical sophistication he kept defending. Tesla's vision wasn't just about gadgets or pure engineering. It was also about sensing and cooperating with those hidden rules of physics that people don't always notice. He treated energy less like a sellable item and more like a natural event you can, with caution, learn to command. That mindset gave the machine a singular reason to exist, separating it from basically every other invention around then. There was even something close to a spiritual drive in how he chased it. Still, for all the promise, Tesla never managed to finish big-scale trials or real-world implementations before he died. A lot of his intentions stayed as sketches or as half-formed thinking, waiting for later scientists to finally join in. The fact that the device survived into the modern era and that it can operate in surprising ways feels like evidence that Tesla's thinking was more than daydreaming. It hints at possibilities science is only now beginning to scrutinize. Tesla's ambitions leave us with a tough kind of challenge. It presses us to rethink how we talk about energy and innovation. What he was attempting to build was basically a new paradigm, not just an improvement, but a different kind of question. One that probes the boundaries of our current technology and opens doors to a future that could look radically different than what we assume is normal. As these ideas echo into the present, it becomes crucial to understand the world Tesla worked in and why such a groundbreaking machine was left behind. Historical context of the 1940s. The early 1940s were a tumultuous time marked by global conflict, rapid industrial growth, and significant technological shifts. The world was entrenched in World War II, shaping priorities around resources, military innovation, and economic survival. In this environment, unconventional technologies often struggled to find funding or attention, especially those that could disrupt powerful existing industries like oil and electricity. Tesla's machine, with its revolutionary promise, was caught in this complex web. Tesla was working in relative obscurity during this period, overshadowed by the towering scientific achievements related to radar, nuclear physics, and aeronautics. Governments and corporations focused on immediate wartime applications, leaving little room for speculative inventions. Although Tesla's machine could have offered a new energy paradigm, the urgency of war and skepticism toward radical ideas delayed any serious development. This context helps explain why the device was shelved rather than scaled. Economic constraints also played a critical role. Funding for novel research was limited and heavily controlled by entities invested in traditional energy sources. Tesla's declining health and financial hardships further prevented him from advancing his projects. Despite his prolific career and groundbreaking discoveries, the support needed to bring this particular machine to fruition simply was not there. Moreover, the period saw significant technological conservatism, where scientific institutions hesitated to endorse ideas that challenged established physics. Tesla's theories about radiant energy and the new mechanics embedded in his machine clashed with prevailing paradigms. This cultural resistance made it difficult for such machines to gain traction. Even with Tesla's reputation, his late career inventions were often dismissed or ignored. The machine's abandonment also reflected broader geopolitical shifts. After the war, the focus shifted to rebuilding economies along familiar industrial lines, further sidelining experimental technologies. Strategic interests favored fuels and infrastructures that could be controlled and taxed, leaving the idea of free energy systems off the table. These forces shaped the fate of Tesla's invention. During this era, documentation and equipment related to Tesla's projects became scattered or lost, buried in archives or private collections. Some researchers speculate that certain inventions were deliberately suppressed to protect vested interests. The machine's disappearance into obscurity fits this pattern of forgotten innovation entwined with political and commercial agendas. Tesla's machine existed in a fragile space between breakthrough and neglect, its fate sealed by circumstances beyond pure science. Its reactivation decades later forces us to reflect on the interplay between genius, history, and power structures that determine which inventions survive. This understanding enriches the mystery surrounding the device and emphasizes how close the world came to changing course. Today, as the machine hums back to life, it carries the weight of history with it, a symbol of ideas buried and rediscovered, of a moment when the future might have taken a different path. Illuminating this context helps us appreciate the full significance of Tesla's creation, far beyond simple mechanics. The story of Tesla's forgotten machine is inseparable from the era that forgot it, offering lessons on innovation, timing, and resilience that still resonate. With this historical backdrop in mind, the science embedded in the machine becomes even more remarkable, opening new questions about what Tesla discovered and how it outpaces even today's understanding. The science behind the machine. Tesla's forgotten machine is kind of unlike conventional electrical devices because it works on principles that push back on mainstream physics a lot. At its core, the setup looks like it is made to pull in what Tesla called radiant energy, meaning an energy type that moves invisibly through the surroundings and keeps being replenished by cosmic plus solar sources. This idea feels radically separate from classical electricity, which leans on moving charges through conductor wires and transformers. Instead, Tesla's contraption tries to use up ambient energy fields, turning them into practical power via resonance, oscillation, and a kind of steady back and forth. Key to how the machine operates are several carefully arranged coils plus capacitors, all wired in a bit of unconventional, almost fussy ways to end up making particular frequencies of electromagnetic waves. People who studied it later said those waves don't just travel through stuff, they interact with the environment and then somehow amplify the energy input in ways that feel surprising, maybe even rude. Unlike normal generators that either chew through fuel or lean only on incoming electricity, this contraption looks like it is stimulating energy from around it. So then, a kind of feedback loop could form and keep going on its own. That part might also line up with those strange energy results seen during reactivation. One especially baffling bit is that it uses high-voltage, high-frequency currents, along with particular circuit geometries that don't behave like you expect. Tesla thought those conditions could let it resonate with Earth's electromagnetic field, basically tapping a global source instead of only taking from your immediate surroundings. If that is right, the extra power that was recorded could make sense because the machine output would be effectively coupled, not just locally, but to a worldwide energy reservoir. Modern tests have had a tough time reproducing the exact mix of conditions, so the whole thing stays a little mysterious even now. Also, the device includes parts that seem to juggle magnetic fields and electric fields together, in tandem sort of fashion, and this approach kind of anticipates today's work on magnetoelectric effects and quantum electromagnetism. Tesla's grasp of these couplings showed up decades early, before many of the theory people later built actually existed. In a way, the machine sits half in classical physics, half in emerging quantum models, so it ends up being hard to analyze cleanly with standard lab equipment, at least by ordinary means. Despite the complexity, the machine was made with this kind of uncanny craftsmanship, using dense winding patterns and insulating materials picked mostly for their dielectric behavior. The careful engineering hints that Tesla, somehow, grasped how material properties steer electromagnetic reactions when frequencies get high and restless. Even components that have held up for around 80 years show his focus on durability and usefulness, not just this brief trial-and-error vibe. Right now, some researchers are saying they found subtle harmonic relationships inside the machine's circuitry, where the frequencies made by different coils line up and kind of help each other along. That harmonic resonance could be a decisive piece for uncovering hidden energy paths, almost like tuning forks, but in a different register. They amplify sound waves by coincidence timing. If the machine is matched just right, it may persuade energy out of sources that were previously out of reach. Tesla's forgotten machine sits there as a symbol, like advanced scientific instinct arriving before the formal models catch up, sometimes by decades. If its secrets are actually unlocked, it might open doors to technologies that today, honestly, sound too fictional to be real. Understanding this complex science sets the stage for revealing how the machine came back into the hands of researchers and the remarkable story of its rediscovery and restoration. Rediscovery and restoration efforts. The revival of Tesla's forgotten machine began with a chance discovery in a remote archive, where dusty crates contained incomplete parts and blueprints, long thought lost. Careful examination revealed the machine's original components, many preserved surprisingly well, despite decades of neglect. The restoration team faced immediate challenges. The physical condition of the device was fragile, and documentation was sparse, requiring researchers to rely heavily on Tesla's original notes and modern interpretation to reconstruct the necessary systems. Meticulous cleaning and repair of delicate copper windings and aged insulation were essential first steps. Specialists in precision electronics worked to replace corroded connectors without compromising the machine's original integrity. The restoration demanded a unique blend of historical craftsmanship understanding and cutting-edge material science to ensure the machine would operate safely and effectively again. Because Tesla's notes were often cryptic or incomplete, scientists had to carefully test various hypotheses on wiring configurations and input frequencies. Trial and error became a foundation of the work, with sensors installed to monitor every electrical fluctuation. Early power attempts were cautious, using limited voltage boosts to avoid damaging the system, which made the slow progress both tense and exciting. As the restoration progressed, small successes spurred renewed enthusiasm. Researchers were astonished when the machine produced stable oscillations and electromagnetic pulses consistent with Tesla's descriptions. These results confirmed that the team was on the right path, overcoming decades of theoretical and physical decay. With every powered test, confidence grew that Tesla's machine could again function as intended. Throughout the process, multidisciplinary collaboration was crucial. Engineers, historians, and physicists combined their expertise, allowing insights into not only the machine's mechanics, but also its philosophical and scientific context. This cooperation led to new interpretations of Tesla's writing and patent sketches, shedding light on obscure design elements that might otherwise have remained mystery. The restoration also highlighted Tesla's foresight in choosing materials and construction techniques that could withstand the passage of time and environmental stress. This durability was vital to the machine's resilience and helped maintain its function after 80 years. The longer the team worked, the clearer it became that Tesla intended his inventions to last, in both technology and impact. With the machine restored and operational again, the next chapter lies in assessing how this extraordinary device has stirred the scientific community and what possibilities it might unlock. The excitement felt among researchers mirrors the broader waves of curiosity and caution rippling through the world of science today. Reactions from the scientific community. The reactivation of Tesla's forgotten machine sent shockwaves through scientific circles, kind of in this messy way, sparking a mix of skepticism, curiosity, and cautious optimism all at once. A lot of experts at first came in with doubt, asking if the reported outputs were truly there, or maybe just measurement errors doing their thing. After all, extraordinary claims need extraordinary evidence, and Tesla's history of pioneering yet sometimes hard-to-read inventions only made people press harder for rigorous checks. So scientists started re-examining the test data, trying to split what was mostly hype from what was actual performance. Then, as more independent labs confirmed the machine's unusual power patterns, the overall mood began to tilt. The fact that it could sustain energy outputs beyond what people normally expect rattled long-standing ideas about energy conservation and where generation even fits. People started talking about whether it was drawing from previously unrecognized physical phenomena or whether there were cracks somewhere in the usual energy models. That discomfort didn't stay small. It opened bigger arguments, not only about Tesla's device, but also about physics topics that had been long ignored or just quietly skipped over. Some researchers sort of compared the machine to earlier versions of what is now being called over-unity devices, meaning systems that seem to put out more energy than what they take in. It's still controversial, but these ideas nudge at the edge of accepted science. Even so, skeptics stayed uneasy about whether results can really be reproduced, and they also warned about confirmation bias, basically saying there has to be transparent, repeatable experiments with full disclosure, no shortcuts. That push-pull between suspicion and openness is, honestly, a normal part of scientific progress, but it also keeps feeding the public's fascination. The machine also turned the spotlight back onto Tesla's wider legacy, and suddenly, people paid more attention again to his writings on radiant energy and wireless power transmission. Scholars and engineers went back over old patents and long-ago notes, trying to figure out the theoretical base bit by bit. Some praised Tesla as a misunderstood genius, someone whose ideas were ahead of their time. Others cautioned people not to romanticize work that was incomplete or still kind of speculative. Either way, the conversation brought extra scrutiny to the historical setting around Tesla's inventions. Among notable physicists and electrical engineers, the machine sparked practical questions too, like whether the effects could be made useful in a consistent way on a larger scale. People kept worrying about scalability, efficiency when conditions change, and how it would even connect with the existing energy grids. Still, the thought that the device might help enable new kinds of sustainable energy kept discussions leaning optimistic. In that sense, the machine symbolized a potential paradigm shift, yet many insisted it was way too early to start rewriting textbooks. Academic conferences and research institutions started inviting experts who were involved in the restoration stuff to share their findings. The openness, in a way, pushed interdisciplinary collaboration along, and it kind of brought together quantum physicists, materials scientists, and electrical engineers. Workshops then started appearing around the idea of trying to understand the machine's operation, kind of inside the frame of emerging theories such as quantum field fluctuations and zero-point energy. In practice, Tesla's invention turned into a spark for poking around in scientific places that weren't really mapped yet. With all these mixed reactions going on, the more cautious voices kept insisting on patience. They argued that rigorous peer review and reproducibility should come first, before the machine is treated as something bigger than a promising anomaly. The risk of pseudoscientific hype was still hanging in the air, and it reminded folks that years and decades of free energy claims have so often ended in disappointment. Still, the revived Tesla machine remained this real, physical reminder that maybe knowledge is sometimes hiding just beyond the current limits of understanding. As excitement mingled with skepticism, attention naturally turned toward what practical benefits such a machine might offer our modern world. Potential modern applications. The successful reactivation of Tesla's machine opened the door to bold ideas about a future where energy scarcity could become a thing of the past. If its reported ability to draw power from ambient radiant energy could be scaled, it might reshape the way homes, businesses, and cities access electricity. Cleaner, cheaper, and more sustainable power could reduce dependence on fossil fuels while lowering environmental damage. One of its most promising uses would be off-grid energy. Remote communities, emergency shelters, and critical facilities could benefit from a compact power source that does not rely on fuel deliveries or fragile supply chains. In disasters or isolated regions, that kind of independence could be life-changing. Transportation could also be transformed. Electric vehicles still depend on batteries, charging stations, and limited range. A self-sustaining radiant energy system could potentially extend travel distance or reduce the need for constant recharging, changing the future of mobility. Industries might benefit as well. Factories consume massive amounts of energy, and even partial integration of Tesla-inspired systems could cut operating costs and reduce pollution. Medical and scientific equipment may also gain from stable, uninterrupted power, especially in advanced imaging, therapy, and research tools. Still, major challenges remain. Engineers would need to improve materials, safety systems, scalability, and compatibility with today's infrastructure. Combining Tesla's principles with modern nanotechnology, quantum computing, or advanced electronics could push the concept further. For now, Tesla's machine remains a powerful symbol of possibility. Its true value depends on research, collaboration, and cautious optimism. From the science-inspiring dreams to the practical horizons it reveals, Tesla's machine stands poised between past ingenuity and future possibility, unanswered questions, and future research. Even with progress in reactivating Tesla's forgotten machine, a lot of questions stay open. Researchers still do not really grasp its unusual energy behavior or the way it looks like it's drawing power from nearby sources. Some ideas hint at zero-point energy, while others lean toward quantum effects, but none of it has been nailed down. That uncertainty leaves the whole machine balanced right on the edge of modern science. One huge hurdle is stability. First tests might look promising with odd output, but keeping that level for a long time is tricky. Investigators still need to sort out energy losses, how durable the parts are, and what the surroundings do to it before the device can step past prototype status. Scaling the machine is another problem that still feels unanswered. A small experimental model might behave in a way that's kinda different from a bigger system built for homes, industries, or even whole power grids. The electromagnetic interactions need to be carefully modeled and then tested before anyone can really talk about real-world use considered. There's also more attention these days on how Tesla's original ideas connect with modern science. Some people think his work was kind of ahead of the curve, like anticipating angles from quantum electrodynamics or magnetohydrodynamics. But tying those theories to the actual machine behavior means deeper research across physics, materials science, and electrical engineering. And well, that doesn't happen overnight. On top of that, security, ownership, and regulation are becoming pretty major concerns. If the technology ends up being practical, it could disrupt energy markets and also bring up ethical questions, like who gets access and who controls it. Funding stays another hurdle, especially since the machine is still viewed as speculative. Still, improvements in sensors, nanomaterials, and computing might help researchers finally uncover how it works. If there's stronger collaboration between independent inventors, universities, and industry, Tesla's machine could become a bridge between overlooked genius and future energy breakthroughs. Tesla's forgotten machine has reawakened a century-old vision, blending mystery and science in ways that could redefine energy as we know it. Its revival reminds us that innovation often lies just beyond today's grasp, waiting for curious minds to rediscover it. If you found this journey into Tesla's legacy as fascinating as we did, please like this video and subscribe for more stories where history and science collide.